Welcome to the second TeraFlow Hackfest. So thank you, Sylvia, for the introduction, and thank you all to being here. So it's very good to see such a lot of faces, new faces, old faces. That's very good, and I think that helps us to improve the community, to visualize that we have interest, that there is still interest in what we are doing, and that we would like to foster how SDN will be in the next decade. So most of us say, okay, why are you talking still about SDN? That's one of the questions I always get, and I say, okay, we think that we are talking about network programmability, we are talking about network automation, but we need the tooling for doing that. And the tooling for doing that is having SDN controllers. And to have SDN controllers, we think that there is not enough innovation in what was in the market, and that's the reason why we created TeraFlowSDN. So that's why you are here today, to learn a little bit more about it, TeraFlowSDN, to join the community. We are more than welcome. If you look interested, you are happy. We will happy to onboard you on board, and also have our regular meetings and to contribute to the different opportunities that we have for TeraFlowSDN. So I'm Ricard Vilalta. I'm the chair of TeraFlowSDN, and Luis is the chair of the technical steering committee. We will be presenting the Hackfest today. And I will introduce with the theoretical part, and then because I'm not able to do the practical part, so I will also be a participant of the Hackfest. But then Luis will guide us through that practical part. So first of all, first things first, if you have time, you can download from the internet the virtual machine. If you want to save time, you can simply get some of the USB drive that come here. It's a preloaded virtual machine that you should be able to install, and it's all packed in so that you don't need to worry about what needs to be done. So we just take the USB drive. In front we have some USB sticks. Just let us know, and make sure that you have your TeraFlow inside your computer, and also you have your TeraFlow outside your computer. So please take some of the stickers, and then you plug them outside so you can visualize our community. So that's all the details, the user and password, and the networking that we recommend. It's quite standard, but just in case. So inside the VM, you will have these commands. These are all the commands that we will be needing these days for the challenges. They are also available on board. You can see that this is a release that we have done for the Hackfest, but you can also find them in the virtual machine. Also, you can use the proper environment. You need to update from the Git repository just for the last minute hacks. And that's it. After this, you can start. So the agenda, as Sylvia said, it's quite packed. So let's start. I will be doing the 101, and then we will jump to the meat of the day. So let's motivate this. I have just tried before. So why SDN is different? This slide deck, I have been using it for the last 5-7 years. It helps me introduce the motivations for the SDN. So we have typical traditional architectures. So where we have OSS, BSS systems, operation support system, business support system. Then we have our NMS and EMS. Then we have the network equipment. This is the pile, typical traditional pile you can find in every operator's network. Then we are evolving, and you say we are evolving to almost the same. So what is the difference? So the difference is not in standardized management interfaces. This has been in the market for the last 20 years, maybe, or 30 years. SMIP protocols, MIB tables. So these are pretty standards, pretty old. So the difference is not here. A standardized architecture. We have been standardizing our architectures for the last 40 years. Partly not the open interfaces, partly not even the use cases, but the difference is new ways of thinking, focus on the applications, where's the value, Where's the use case? Applications take control over the service. So intelligence, right now, this is before all the ML trend, but the intelligence is where the decisions are taken, and you are able to take decisions on top of the network. Of course, you need open source based development for that, and also simplification through abstraction and virtualization. So some of the principles of SDN, we have programmability, openness, and integration focus. So openness is not only about open source, but opening your environment. So you will find companies that are very open and they are not doing open source. So that's something that's different. We think that open source is the way to go, so that all the companies can benefit and the ecosystem benefits for faster innovation. But then also for the integration, if you want to integrate, openness is not enough. Open source enables to integrate faster and better between layers and between vendors. So there are different benefits. I will not go into details. And for us, we have two different metrics of success to be applicable to our TeraFlowSDN. First of all is the multi-industry, multi-vendor interoperability, so that it is able to provide agnostical vendor support for the different network configuration and automation. And then we want also industry adoption. So we want to see TeraFlow in a path where it goes to the market. And for that, we need to have industry adoption in somehow. We need POCs. We need involvement of the product. We need some companies that provide support to the product, and so on. So we are defining a roadmap for the product, TeraFlowSDN. So, and for that, we need to break the silos. We need to avoid from silos of the hardware to the software, and we want to avoid the new silos of management. So we have full stack architectures. For that, we need some new kind of SDN controller, where we see different parts of the network which are needed, and this kind of paper preparation lead us to TeraFlowSDN architecture that I will later present. So when people talk to me, I always hear the same question: Ricard, why do we need yet a new SDN controller, with a big emphasis on the yet? And I have only one answer. I mean, is your controller, your current open source controller, enough for handling IP layer? Is enough for handling the need for network automation? Is enough for handling new scalable management of the resources? If the answer is yes to all these questions, of course we don't need yet another SDN controller. But I think that for these three terms I have mentioned, there is no any open solution. So that's why we introduced TeraFlowSDN. So we wanted to support IP scenarios. We wanted to support routers, white boxes, P4 switches. We wanted to support scalability issues. For that, you need to go to a microservice architecture. So that's the importance of TeraFlowSDN. So we have broken SDN controller into small pieces called microservices. You know how this cloud-native way of writing software goes. We have an internal structure for a bus structure for all the messaging between the microservices, and they are able to collaborate to provide end-to-end services. So that's our vision for how a new 21st century SDN controller should be, and that's why we are proposing it. So we are hosted at ETSI. We were funded by European Commission under a research project, but we saw that this was much important than that a simple toy project for having a site and having a GitLab account, and we decided to create a community, and that's why we are here today. So we are a community of developers focusing on network automation. Our way of advancing the state of the art is through TeraFlowSDN. So our microservice architecture is brand new. So you have seen it evolving in the last years. We think it solves and it provides some benefits. Of course, it has its challenges because nothing comes for granted. But if you want more scalability, you want more integrity, you want self-healing mechanisms, all of these are benefits of our architecture. So we think that scalability is a must when we are talking about networks with different network domains, network segments that need to address hundreds, even thousands of network elements, and to control them, we need scalability, and that's why we are proposing this architecture. We are also providing a toolbox to the different groups working on network transformation. As we are saying, we are providing the pipelines for introducing intelligence to the network. So that's, first of all, we need to execute, and execute is what TeraFlowSDN provides. Of course, we are also evolving TeraFlowSDN to be self-conscious, so that it can be able to provide more network automation workflows. So we are evolving. For example, we're introducing all the zero-touch service management principles inside TeraFlow, so we have different control loops. So this is part of the next releases evolution. Then we are supporting different use cases. I will later talk about them. We also focus on alignment of the multi-SDO goals, so and also help to accelerate standardization cycles, because as you see, I don't know if you were yesterday in the workshop, there are too many SDOs, in my opinion, so I will create a new one. That's the solution for everyone. We think that providing open source is a way of aligning SDOs. When there are too many, we provide source code that's more usable, that's more practical, that can be tested, can be improved sequentially. PDFs are not the way of working right now, so we are focusing on Python. And that's also some of the last important things. We are part of an ecosystem. We have seen how operators in the telecom infrastructure project have aligned to request to do some requirements for the network automation purposes. They call them the must requirements. And basically, they have selected some kind of architectures for transport network. They have selected some kind of interfaces. And we want to be a reference implementation of that architectures that they are proposing. And that's why we are aligning with the mass requirements in TIP. And we are preparing a white paper to analyze all the mass requirements and how TeraFlow addresses most of them, and prioritize the work for the next years. And finally, we are open source. We have an Apache software license, so everyone is able to use TeraFlow, to improve TeraFlow, and we are waiting for your contributions. So these are the current members. It's a growing community where there's not a small member. We have members from SMEs, from big industry, from vendors, from operators, and also from academia. So you are all welcome. So please talk with us or with Sylvia if you are interested in joining. This is the architecture I was promising before. So here you can see the different microservices. I will not enter into all the details because I think that now is not the time, but the idea is that we have one scalable database microservice. Let's say it's context. This is the foundstone of TeraFlowSDN, where all the different states are recorded, and then most of the different services, correct me if I'm wrong, Luis, most of the different services are stateless, so that they can be scalable. So we rely on a scalable microservice, which is context, to have a stateless microservice around. And that's how it works. We have then this bus where with the different protocol buffers and gRPC protocol interact between the microservices. Then, of course, we have service, which is another cornerstone. Also, SBI, MBI are very important. So MBI is able to translate outside wall into the protocol buffer that we understand. All the microservices are modeled using protocol buffer. So it's we have an complete internal data model, and then we export it towards well-known data models in the northbound or in the southbound. So then we will discover most of the other microservices. So what you are able to control? So we have an SDN controller, and the question is, what can you use it for. So basic network elements that we are able to handle is, for example, the IP white boxes. Today we will be seeing Container Lab, which is an emulator for different network operating systems of white boxes. If you don't have never seen or heard about a white box, imagine a router which you detach the data plane from the control plane, and the control plane we call it a network operating system, and it's the basis for the controlling what all the different data plane and all the flows that are happening in the pipelines of the router. So this is how we treat, and we are using OpenConfig for that. OpenConfig models for white boxes. This is one of the most important support, but we are also handling P4 switches, for example. So these brand new programmable switches that you can directly install programs and control how they work. And also we are able to support open SDN, optical SDN controllers. So we have introduced a plugin for the transport API, for example, and then we support many other things. Basically, what I say is, if you have a network element that is able to that you are able to control it with a REST API, then you can always write a plugin for TeraFlow, and you can write always a service for TeraFlow to handle all this. So that's what we have, the support for OpenConfig switches. We have tested with Infinera, with ADVA, and we have more in the pipeline. Support for P4 switches. And then today, we release the support for GNMI. So that's something that we will be playing during these 2 days. So we are able to control white boxes. So these network operating systems with a brand new protocol, GNMI. I guess that most of you have heard. We will be using the OpenConfig data models for it, but the protocol itself, it will not be netconf as it was in the past, which is slow and big, and we're using the new GNMI, which is much faster and responsive protocol. And also for telemetry, provides a lot of benefits, as we will see today or tomorrow. Depends on your work, guys. So northbound extensions, how the external wall can interact with TeraFlowSDN. We provide support for layer 2 VPNs, layer 3 VPNs, IETF slice, transport network slice data models. We are introducing new interfaces such as device inventory, ONF transport API, and also MEC interface for bandwidth management. So we are working on it, we are evolving, and when we detect that there is some lack of interface, then we focus on providing it. So everything is in this website, so please check it regularly. We have important dates. We are having a complete week in Castelldefels in October to do the next Hackfest, focus on P4 switches, and also to evolve the ecosystem day. And you will say, Ricard, what's the ecosystem day? Ecosystem day is the community that we are creating in different research projects in order to that they want to use or they want to contribute to TeraFlowSDN. So we started as a research project, we created the community, and now we want to go back and bring back our project to the community, to the research projects, so that it can foster innovation, it can foster research on the different topics. Most of the projects are related to 6G research, but there are some that they are also focusing on security, for example, quantum cryptography, and so on. So you will see that there are many usages and different evolutions of TeraFlowSDN in the near future. So some of the demos that we presented, if you were in the workshop yesterday, I will just fly on top of them. But first of all, integration with our twin project, open source Mano. So we are able to work together. We presented it in OFC 2 years ago. So also some cybersecurity mechanisms that we were using and also presenting at OFC. Then we evolved the source code, and we presented a more complete interface for between open source band on TeraFlow, where we were able to have primary channels, backup channels for the transport network. Then we also focus on DLT, blockchain technologies. So we were able to perform interdomain orchestration, service provisioning with Hyperledger Fabric. Also more focus on network security with a complete suite of tools that allow us to detect attacks in optical networks through monitoring. Then I always say that this is the crown, the shovel of the crown, because this is the first demonstration of a hierarchical TeraFlow. So we are using a parent end-to-end SDN orchestrator, TeraFlow, and different multiple TeraFlowSDN instances for different network domains. So if you wanted to control the IP domain, we used one IP controller, and then we had one TeraFlow to rule them all. So that was the intention, to have this hierarchy, and that was our last demo at OFC. And you will ask me, which is your long-term view, Ricard, on TeraFlowSDN? So what's the evolution? What will come next? So we need to evolve it more. We need to push it for a greener version of TeraFlow. So you see plenty of green in the figures. So we need to provide support for more sustainable networks. So energy will need to, low energy devices, low energy consumption will need to play a role in TeraFlow. We are handling multi-domain networks, so IP over optical networks. Optical networks are very energy efficient. You can reduce the carbon footprint by moving flows from the IP layer to the optical layer. So this is one of the next evolutions of TeraFlow, to be able to have these intelligent algorithms that support this migration of flows from the IP layer to the optical layer, so you optimize the energy consumption. That's one of the topics. Another topic is what we call the edge cloud continuum. So we no longer are on the edge or on the cloud, we are in between, and networks are a continuum of computation resources from the SmartNIC even to the cloud servers, and we need to provide support for that. So that's also one of the things that we want to do. Of course, we need to accelerate support for this disaggregated hardware and software evolution. So that's also another point. Zero trust networks. So we need to have more resilient networks. That's why we call zero trust networks. We have network equipment that is from different domains, that is from different providers. We want to have some trusting mechanisms in our networks, and that's the evolution for that. And always avoiding industry fragmentation. So we don't want competing standards, we want to align standards, we want all the vendors to align, and that's why we are providing open source. So there are two evolution paths that we are seeing. One, as I said, towards an end-to-end sustainable data plane evolution, where we have end-to-end orchestration between the ORAN, service and management orchestrator, and the transport that TeraFlowSDN is representing. We also want a more accountable edge and cloud continuum, where we sustain the system integrity, self-preservation, and accountability. So if we see how a future 6G network will look like, this is the evolution that we are foreseeing for TeraFlowSDN and how it fits into that model. So you can see that we have here the ORAN, the near real-time rig. We want it to interact directly with our SDN controller. We have the backhaul controlled with TeraFlowSDN. We have also the backhaul control. This is the core part controlled by Mano, but also we want to control from TeraFlowSDN, for example, offloading of different elements of the 5G core directly to the switches. So these are P4 switches, for example. You have may heard that UPF from the 5G core can be inserted into a P4 switch. So that's something that we would like also to evolve. So there are a lot of things that in a future near midterm 6G network, TeraFlow could fit, and we want to be part of that game. So that's all from my side. I hope that I have chased your interest in TeraFlowSDN, and I will be around. So if you have any questions, you just let me know. And now Luis will come with a funny part.